Good. Have you ever noticed that there's not a word in English for like that 2 a.m.? Like so many languages have a word for that. Like in Portuguese it's madrugada, and in Korean it's sebyak, but in English there's no word. So anyways, good good 2 a.m. Welcome. We continue today with the educational technology of the future. And it always will be. Ha! It looks like he was wrong. Tutorial dialogue. The technology always seemed exciting, but it always seemed too expensive to really develop for a wide range of content. But suddenly, thanks to large language models, it's tantalizingly within reach. The classic dialogue tutor is AutoTutor.
An airplane flying horizontally drops a packet on a pre-selected spot when it is right above the target. Does the packet hit the target? Explain.
The packet will hit the target because it'll fall straight down.
Good job. Okay, what else can you say?
When gravity acts on the packet, it'll cause it to fall straight down.
Good. Think about this. What can you say about the packet's velocity at the point of release?
The horizontal velocity of the packet is the same as the plane before it's released and after it's released.
Good. Try this. The velocities of the objects before and just after the packet's release are
The same.
great. We're almost there. Let's try to tie up the few details. Note that the velocity of the packet is the same as that of the plane at the time of release. Let's try this together. In which direction is the velocity of the packet at the point of release?
The only force acting on the packet is the force of gravity, and at the point of release, the packet has the same horizontal velocity as the plane. So I guess it won't hit the target, it'll go past the target.
Okay, try this. Immediately after it's released, the packet has the same horizontal velocity as
Constant.
no, the plane. Note that the velocity of the packet is the same as that of the plane at the time of release. Let me help you a little. What can you say about the velocity of the packet after release? Brilliant. Anything else?
How does it work? To learn, we go to the maestros, Art Gracer and Kurt Van Lane. Alas, no dialogue tutors available for either of them, but they have been kind enough to put slides on the web, which I will be using with permission. So Van Lane created a framework for thinking about dialogue tutors, where he said, human tutorial dialogue is a sequence of episodes, one per step. So you see in this dialogue, there's 3 steps where they're going through the process of coming to a solution. And so you can make a schematic of a tutorial dialogue where you have a problem statement, a set of steps, an answer, and then optionally a reflection on that answer. And this graph from Kurt Van Lane breaks down a single step where you start the step, top left, and then the system can either tell the student something, in which case it ends the step, or elicit something. If it elicits something, if it asks the student to respond to something and the student's response is fully correct, then the step ends. If it's incorrect, then the system has to engage in remediation with a hint or a prompt or an explanation or an analogy or something, and then it starts a new step. And as Van Lane notes, experts tend to have a wider variety of things they do when they elicit and the student's response is incorrect. So this is a fairly simple process. How does it work in the most complex and complete system before our large language models, AutoTutor? And for this, we go to some slides from Gracer. So what does AutoTutor do? It asks questions and presents problems. Why? How? What if? What's the difference? It evaluates meaning and correctness of the learner's answers. It gives feedback on those answers. A face displays emotions and some gestures. It gives hints. It gives prompts for specific information. It adds information that's missing. It corrects bugs and misconceptions. It answers student questions. And most importantly, it does all this while holding a mixed initiative dialogue in natural language. The pedagogical design goals of AutoTutor: simulate normal human tutors and ideal tutors. Engage in active construction of student knowledge rather than information delivery. And you may remember this debate from the first week of class. Engage in collaborative answering of deep reasoning questions. Conduct approximate evaluation of student knowledge rather than really detailed student modeling. To get there, Gracer and his colleagues analyzed hundreds of hours of human tutors in different topics, involving studies both in their own labs and also studies from other labs. They noted that there was a whole lot of pedagogical strategies out there that people talked about as things tutors do that actually unskilled tutors and most even expert tutors don't do. Things like the quote-unquote Socratic method of getting people to build up answers. And funny little side note here, if you've ever read any Plato, the one person who really never uses the Socratic method is Socrates. Oh my gosh, never uses it. Tells all the time. But also things like modeling, scaffold fading, reciprocal training, anchored learning, complex error diagnosis and repair, prerequisite structure, so on and so forth. Most tutors don't do these things. So AutoTutor was built to try to emulate not the most fancy tutors out there, but a regular tutor, where basically the system can address errors and misconceptions and can look for what it's expecting and say, did the student express something I'm expecting? Did the student fail to express something I'm expecting? And did the student express something weird I totally wasn't expecting? And so AutoTutor is built on a lot of different technologies shown on this screen. The architecture is quite complex. We're not going to go through all these details, but feel free to pause the lecture right here and just look at this for a minute if you want. One AutoTutor turn involves giving short feedback on the student's previous turn, advancing the dialogue by one or more dialogue moves connected by discourse markers, and then ending the turn with a signal that transfers the floor to the student, like a question or a prompting hand gesture or a head signal. Some dialogue moves include positive immediate feedback, negative immediate feedback, neutral immediate feedback, pumping for more information. What else? Giving a hint, prompting for specific information. Vertical acceleration does not affect horizontal. Asserting even, telling. Correcting, repeating, and summarizing. And so, for example, when a student gives a response, the system might have 3 things it thinks the student might say, and it'll try to use NLP to match to the closest of those and then respond based on that. And it selects the next expectation based on the student's response, also based on not selecting things the student's already covered, and trying to set up a query that will set up the expectation to be things that it thinks the student can get next that are coherent with what they've already done. And how does AutoTutor know which dialogue move to deliver? It's got a set of fuzzy production rules, which you may remember production rules from past weeks, which kind of help it to figure out what to do. And the dialogue advancer network actually is pretty complex based on those 15 rules. Again, we won't go through all the details, but feel free to pause if you want. Overall, it engages in cycles of hinting, prompting, and asserting. So if a student doesn't get something right, it first tries to hint them, then it tries to prompt them, and then it tries to assert. And each cycle fleshes out one expectation, tries to improve the answer in one way, kind of one step forward. In general, the goal is that the student provides the information whenever possible. If the student just can't get it, even after pumps, hints, prompts, and assertions, then the tutor will just give the answer. The system involves a speech act classifier, involving older generation NLP, but still achieving 95% accuracy. There are certainly a lot of challenges to it. You know, newer technologies don't have these limitations. They have newer ones, crazier ones. AutoTutor is pretty effective. It gets an effect size of 0.75 standard deviations, which is better than unskilled human tutors, not necessarily quite as good as some intelligent tutoring systems like Cognitive Tutor. He has here at the bottom of the slide 2 sigma for skilled human tutors. Van Lane's work, as I think we talked about earlier in the semester, has pretty effectively debunked that is a benchmark. But yeah, it's pretty good. It's a good system. It's also an incredibly expensive system to develop content for. So Shengyan Hu developed Auto Tutor Lite, which is much easier to develop content for. Auto Tutor Lite is designed for easier authoring. It does not offer the full range of semantic analysis methods for NLP. It has a much more simplified student model and much less dialogue flexibility. But in exchange, it's much more feasible to author content for. Another scientifically important dialogue tutor is It Spoke by Diane Littman and her colleagues, which is another dialogue tutor where students actually speak out loud. And it was built on another tutor developed by Van Lane, which I think I might have assigned a paper for. Can't remember for sure. As well as just transcribing the text and responding on it, it also can detect uncertainty or confusion from the student's speech patterns and tone of voice. And it responds to uncertain correct answers, where the student got it right but sounded like they weren't sure, by giving additional info on why the answer is correct and continuing the discussion. Despite that kind of awesomeness, that clear awesomeness, it did not improve learning outcomes over a system that didn't have the uncertainty confusion detection. So it still helps learning, but it doesn't benefit learning more than a system without the speech pattern and tone of voice detection, kind of disappointingly. The largest scale use of dialogue tutors before large language models was Watson Tutor, developed at Pearson, which was a large-scale use of a system like AutoTutor for several courses. It also added multimedia hints. Now, papers on it were vague about what courses it was integrated into, but one of the papers shows examples from what appears to be middle school physical science. The system has a variety of behaviors. You can see here dialogues for handling a partially correct response, managing a struggling student with a motivated text, responding to a question by a struggling student, reinforcing a learned concept, and dealing with classification errors. So Watson Tutor was super expensive to build. I don't actually know how much it cost to build, but let's just say a whole heck of a lot of money. And tragically, it's gone now. I don't entirely know why it was discontinued. It seemed to work. It seemed to be a great system, but one day Pearson decided to discontinue it. I never heard the story. Another recent dialogue tutor is Corbett ITS, a dialogue tutor for data science that generates responses using a foundation model AI. It breaks a student answer into cause-effect components and matches those components to reference answers using BERT, a foundation model one generation before GPT 3.5. In specific, it generates feedback based on example responses for other topics, correct reference answers, using BERT to combine those into feedback for the current question, and then using an algorithm that ranks possible responses based on foundation model detectors of sentence, well-formedness, perplexity, that's a bad thing, likelihood of leading to complex non-yes-no responses, and the semantic relationship to the desired target sentence. It deals with 4 feedback cases: an incorrect cause and incorrect effect, an incorrect cause alone, an incorrect effect alone, and a missing cause. And here you can see some examples of those 4 cases. The system adapts questions for students of different overall ability while retaining the same answer. Most notably, and a system that's really exciting, which I think we've talked about a couple times this semester already, is Conmigo based on GPT, and specifically GPT-4. This timetable here shows the history of development of Conmigo, shared by permission from Kristen DeCerbo, and you can see that across a span of only 7 months, they were able to develop this system. The prompt that was given to GPT was built around Gracer, Person, and Magliano's tutoring strategies paper. In fact, it literally referred to it. And the biggest challenge was prompt engineering to get Conmigo to not just give kids the answer. They used extensive reinforcement learning based on human feedback to shape the behavior, where team engineers repeatedly typed possible student input and then gave thumbs up or thumbs down to student input and combined that thumbs down with recommendations of alternate responses that Conmigo could give. And interestingly, the Conmigo RLHF is embedded in the publicly released ChatGPT 4, which is kind of funny because actually if you ask ChatGPT a question about Conmigo, sometimes it gets confused and thinks it is Conmigo. Conmigo does not control GPT, and OpenAI breaks them with updates too. So that requires OpenAI to do extensive, continually rerun tests to make sure things don't break or get worse, either because of work done by the Conmigo team or because of changes to GPT under the hood. Another ongoing challenge is reducing the number of mistakes that Conmigo makes. It's quite accurate at math, but sometimes if a student makes a big enough error, it gets confused about what math problem the student's supposed to be working on and starts to respond to that. And GPT can also miss some student mistakes. Does it work? Sure seems to. There was a harsh article in the New York Times, but it looks pretty good. But the RCT hasn't been published as of this speaking. So give it some time. It takes a little while to run RCTs. I actually expect to see positive results, but there's no substitute for actually seeing the data. As W. Edwards Deming once said, "In God we trust, all others must show data." Overall, dialogue tutoring of large language models definitely looks like it works. It engages in very sophisticated behavior, but does it lead to better learning? And can it be guided to tutor like an expert human tutor does, while being quickly and cheaply adaptable to a wide range of learning domains? It's one of the exciting questions of our upcoming era of research. Unfortunately, most approaches for doing it have been far less sophisticated than Conmigo, so I tend to suspect that a lot of them just won't work nearly as well. There's a lot of web pages out there that will give you dialogue tutoring on the cheap, which is fantastic if you want something that looks good for 5 minutes, but boy, you try to do these prompts multiple times, you'll find they're very repetitive. You try to do it over several responses, you'll find that they degrade heavily. Ultimately, Conmigo is a system that a lot of work went into. So large language models are a magic box, but that doesn't mean that they can solve all problems in 15 minutes, and it doesn't mean that the query or prompt that you can make in 15 minutes is going to be competitive with Conmigo. As discussed earlier, there's an extensive literature on how to tutor well. Simple prompts like the last two I showed are not going to replicate that. If we were to build all the field's knowledge into our instructions to a large language model, then, well, we'd have what Conmigo is trying to do, although to be fair, there has been work other than Gracer, Person, and Magliano, but it's a great place to start. So some key takeaways. Dialogue tutoring is highly effective. Dialogue tutoring is highly complex. Dialogue tutoring is highly expensive. Or is it? Large language models might be in the process of changing everything. It's a super exciting time to be in this field. Thank you very much. See you next week.